Alright, so today we're going to start multi-step equations. The directions say to solve each equation use two column proofs. So as you can see, I've already started my column proofs for 1 through 4. If you're still having trouble, make sure you go to the prior video and I'll show you a little bit on how to set these up. Now, keep in mind that directions do say verifying solutions, but I'm going to skip that for this video and I'm going to cover it in the next one. So don't worry about verifying your solutions, especially when we're starting off with these multi-steps. I'll let you know when you have to do that in the directions. So just a quick reminder on how we start two column proofs. You always want to start with your equation on the workspace to the left of your column. To the right is your reasoning. Now keep in mind that when you start with your equation, you're starting because that is what was given. So that's what I'm doing to all these problems. I just wrote down my equation and all I did was write given to the right to say, hey, this is what was given to me in order to solve them. Now, make sure that you have this written down somewhere. These are the properties that I want you to clarify when you're using them in your two column proofs. Now, whenever you're doing these multi-step equations, there's going to be multiple steps to each equation. What step to do what depends on what you like to do, but my suggestion is to follow these 4 steps over here to my left. Now, if you follow these 4 steps in those order, 1, 2, 3, 4, and you ask yourself each step as you solve these equations, there's not going to be any equation that I'll give to you that you cannot solve in Algebra 1. So let's start working through these steps and showing you how those apply to each problem. And I'm just going to start with number 1. Whenever I'm given an equation, the first question that I ask myself each and every single time is, hey, can I distribute if there's any parentheses there? Now I can see on number 1 there are no parentheses anywhere in that equation, so I can skip that step. Now let me ask my second question, or my second step, which is to combine like terms on the left or the right side of the equation. Now whenever you have an equation, there are 2 sides. See if you can combine anything on the left side or you can combine anything on the right side. Now looking at the left, I only have a 13, so I can't combine that with anything. Now if I look to the right, I can see that I have a positive 1 and a positive 6. Both of those don't have variables, so they are like terms. I could combine them. That is just a 1 plus a 6, which is a 7. The 3x is just really watching. Now keep in mind what I did there was combine like terms, so I have to clarify with my reasoning, combining like terms. Okay, now that I've combined all the like terms that I can, notice I can't do it anymore with the 13 or the 7x. I go on to my next step, which is move all the variables to one side. Now if I look at this equation, or at least the step I am now, I only have one variable which is on one side already. So there's no need to move them all to one side because there's only one and it's already on that one side, so I don't have to worry about that. Now I just have to solve for the variable. This is all that practice that we've been doing with two-step equations. Always get rid of what you're adding and subtracting. So I'm going to minus 7 on both sides. These cancel out. I'm going to be left with a positive 6 is equal to 3x. Now, what I used there was the subtraction property of inequality because I subtracted 7 on both sides. So subtraction property of equality. Now I'm going to divide by 3 on both sides. These 3 cancel out. I'm left with an x by itself. 6 divided by 3 is a positive 2. And to get to the answer, I used the division property of inequality because, again, I divided by 3 on both sides. So that is one example of how I worked through these steps in that order in order to solve that equation. My goal is to show you 6 examples of how I work through the same strategies or the same steps for each and every single problem, and I arrive to the answer if I follow those steps correctly. So let's continue with examples. So let's start with number 2. I'm going to start with, are there any parentheses to distribute? No. Can I combine like terms on the left or right? So here's my equation so I can visually see the left and the right. I can clearly see that I have a negative 6 and a positive 5 that both don't have variables, so I'm going to combine those. Negative 6 plus 5, when I combine them, becomes a negative 1. And then my minus x is just kind of hanging out there. And my negative 5 on the other side because there's nothing else to combine. Now what I did there is combine like terms. Now I can see that I've combined all like terms. I only have one variable, so that means I can't move them all to one side because there's only one and it's on one side already. So that means I can solve for that variable already. And that is just, again, the two-step equations that we've been practicing. Get rid of what you're adding and subtracting first. So add 1 to both sides. These cancel out. You're left with a negative 4 is equal to a negative x. Now what I did there is add on both sides, so that's the addition property of equality. Finally, we have to get rid of that negative. Now that is a negative x, but technically it's a negative 1x. I like to draw my negative 1 there, so that way I can clearly see that all I have to do is divide it by negative 1. These cancel out, I'm left with an x by itself. Negative 4 divided by negative 1 is a positive 4. So that's the division property of equality. All right, so let's do a little bit more difficulty like 3 and 4. I can clearly see here that there are some parentheses, which is my very first step. I finally get to use that first step, right? When I know how to get rid of those parentheses. The first thing you want to do is just distribute. Your 64 is just out here watching. 4 times 4 is 16. 4 times 3n is a positive 12n. What I used there was a distributive property. Now I keep going through my list. There is no more distribution because there's no more parentheses. Can I combine like terms on the left and right? No, because I have a 64 on one side, I have a 16 and a 12, and I can't combine those. I can't move all my variables to one side because I only have one variable to one side. It's already there, so that means I'm good with that step. Now I just have to solve for the variable. So get rid of what you're adding and subtracting, minusing 16 on both sides. These cancel out. Notice I have 64 minus 16. Have to do my math here. 14 minus 6 is 8. And then finally, 5 minus 1 is 4. So I end up with 48 is equal to 12n. Don't forget your reasoning. I subtracted on both sides. So that's a subtraction property of equality. Finally, getting rid of that 12, I'm going to divide by 12 on both sides and end up with 48 divided by 12, which is 4, is equal to n. I use the division property of inequality to finish up there. All right, so again, go through those 4 steps. Use those 4 steps. Understand how to use them when you see those strategies, so that way you guys are able to solve any problems. So number 1, can I distribute? Are there any parentheses present? And the answer is yes. So I'm going to start off with distributing. 60 is going to be equal to 12x plus 12. I use the distributive property there. Now, looking at my both sides of my equations, I have a 60 by itself on the left. I have 12x and 12. One has a variable that one doesn't, so I can't combine like terms. I only have a variable on one side, so I only have that one to worry about. So that means I got to solve for it. So let's get rid of what we're adding and subtracting. We're adding a 12, so minusing will cancel it out. We're left with 48 is equal to 12x. I subtracted on both sides, so that's the subtraction property of equality. Dividing by 12 on both sides, I finally end up with 4 is equal to x. 48 divided by 12 is 4, and then the 12s cancel out. That is after using the division property of inequality. So again, I know the instructions said to verify. Do not worry about verifying your solution, and that's going to be covered in the next video. Now we have 2 more examples to go forward. I'm going to scroll this up a little bit more so that we have some more room to work. Now, as you can see, these equations are getting gradually more difficult. What I mean by more difficult is there are more steps. But if you follow these steps that I've written down on right over here, you're able to solve anything, any of these problems. So let me write down my 2 columns. Let me start with my equation. That was an ugly 4. Okay. So I wrote it down. That was given. Let's start with number 1. Now, number 1 is asking us to distribute if any parentheses are seen. I can clearly see that there are some parentheses here. So what I'm going to do is I'm going to distribute that 5 within those parentheses. Now, this negative 4 is just watching, so I'm just going to write that down. 5 times x is a positive 5x. 5 times a negative 5 is a negative 25, and that's still all equal to a negative 54. What I used there was the distributive property. Now, I can go on to my next step because I don't have any more parentheses. Can I combine any like terms on the left or the right side? Now, if I look at my left, I clearly see that I have a negative 4 and a negative 25. Those don't have variables, so they're like terms. You could combine them. So that becomes a negative 29. And that is still equal to a negative 54. Again, what you do there, you combine to like terms. Now, do I have variables on one side or both sides? I only have it on one side, so I don't have to be worried about moving them on to one step or to one side. That's going to be covered in the next video as well. All I have to worry about in these ones is to solve for that variable. So get rid of what you're adding and subtracting. These are going to cancel out. You're left with 5x is equal to 54 plus 29. Now I can clearly see that those are different signs. So I'm going to subtract the numbers. Borrowing from my 5, I have a 4. 14 minus 9 is 5. And then 4 minus 2 is 2. So I end up with a 25. Now notice that my 54 is a bigger number, so I end up with a negative 25. If you need help on this, please let me know. There's not going to be a calculator on your test, so you need to know how to do that elementary math that sometimes it's easy to forget. So at the end, let's divide by 5 on both sides. X is equal to a negative 25. Now, what I forgot there was to do my division property of inequality. That is the step right over here. I divided on both sides. On the step before that, notice I added on both sides. So that's addition property of inequality. Some students like to do their work and then go back and fill out their reasoning. I really don't mind as long as it's there and it's in the right order. I'm more than okay with it. All right, so our last example, we have negative 1 minus 4 times 2 plus 3x is equal to 51, and that is what was given. Now, going through my steps, I noticed that my first step is to distribute if there's any parentheses. So there is some parentheses. Let's distribute here. I end up with negative 1 is equal to a negative 8. With a plus there when it should have been a minus. Minus 12x is equal to 51. Because again, a negative times a positive is a negative. So that's why I had to erase that. Now what I did there was a distributive property. Now there is no more distribution, so I'm going to try to combine like terms. So I noticed that there's a negative 1 minus 8, which is a negative 9. What I did there is combine like terms. Now there's only one variable on one side, so that means I could solve for the stuff around it. So let's add 9 to both sides. These cancel out. You're left with a negative 12x is equal to a positive 60. I use the addition property of inequality. And finally, dividing by negative 12, you end up with x is equal to a negative 5. What did you use there? You use the division property of inequality. So now that's pretty much it. Follow those 4 steps and you'll be okay with any problems I give you.